Hello everyone. Today let's solve the problem number 973. K closest origin, K closest points to origin. So you can just go through the question and you can just try to understand the question with the help of examples that they have given. So I'll just summarize the question so that it will be easier to understand. So what the question states here, we are given an array of points of I. Here you can clearly see we have been given an array of points, nothing but the points of I equals x of I comma y of I. So we have here x and y, right? So we have been given the array of points, nothing but points of I equals x of I comma y of I. Basically, it represents points on a 2D plane. It represents a points on the 2D plane along with the integer k. You can clearly see we have the integer k as well. This represents the points on a 2D plane and we have the integer k as well. So what is our main task then? Our main task is to find the k closest points to the origin. K closest point to the origin 0, 0, which is the uh, closest kth closest point we have to find out, not the closest point, kth closest point accordingly with the k that they have given. Kth closest point to the origin 0, 0. Here we have the x and y axis, right? So which is this one closest to the origin 0, 0. In this case, this one from this one 0, 0, right? So from here, the distance between 2 points on a 2D plane is calculated using the Euclidean distance formula. So here they have clearly mentioned the distance between two planes on a 2D plane is calculated using the Euclidean formula. They have mentioned here. See here, square root of x1 minus x2 square plus y1 minus y2 whole square. Square root of x1 minus x2 whole square plus y1 minus y2 whole square. This is nothing but the Euclidean distance formula. So the distance between 2 points on a 2D plane is calculated using the Euclidean distance formula. They have clearly mentioned here square root of x1 minus x2 whole square plus y1 minus y2 whole square. Just keep this one in mind. So since we are only concerned with comparing the distances, we can ignore the square root and just compare the squared distances. So they have not mentioned here. By understanding the question, so I'll just we can just come to the conclusion here. Just keep this one in mind. Since we are only concerned with comparing distances, right? So we can just ignore the square root and just compare the squared distances. When I say squared distances here, this will be distances, nothing but square distances we are going with, right? So d square equals x square plus y square. So this is the formula that you have to keep in mind. Nothing but distance. D is nothing but the distance. X and y. X we are considering right here. Distance square. D square equals x plus y square. Just keep this formula in the mind. So basically this avoids unnecessary floating point calculations and makes our solution efficient. This one we have to consider this one. D square equals x square plus y square. Just keep this formula in mind. I hope the question is completely clear. Initially what we'll do, as usual, we'll be discussing the approach. Then let's dry run this example and then let's discuss the edge cases one by one, then finally write the code and discuss the complexities of the code that we have written. In this example, you can clearly see what we have to calculate. Basically, this one, we have to find the k closest points to the origin 0, 0, right? So in this case, if you consider this one, first example here, you can clearly see they have given 1, 3 and 2, minus 2, 2. K they have given 1, right? We have to find only 1 here. Closest, this one, closest point, only one closest point here, sorry, from 0, 0 here. So if we consider 1, 3, this one is at 1, 3 here. They have mentioned here, you can clearly see here, right? 1, 3 and minus 2, 2, you can clearly see here. When we go with the formula d square equals x square plus y square, we are just let's just go with the formula. that I gave here, right? So d square equals x square plus y square will be going with. So let's do the dry run later. So let's understand this one is the closest to the origin 0 comma this one 0 comma 0. So the output we have to display here is minus 2 comma 2. So we have to give only one this one, right? In this case k equals 1 they have given, so we have to display only one closest point here, nothing but minus 2 comma 2 in this case. Same goes with the example 2 as well, right? So we can just consider here, in this case they have given 3 comma 3, 5 comma 1 and minus 2 comma 4. K equals 2 they have given, so we have the two closest points here, nothing but 3 comma 3 and minus 2 comma 4. So this would also be accepted, they have given here minus 2 comma 4 and 3 comma 3. So we have two answers, anything. So nothing but they have given this one first and this one second in this case, right? So I can just check for this one as well by considering the same figure, right? So I hope the question is completely clear. Let's discuss the approach part first, right? So let's discuss the approach first and try on this example, the first example that they have given. The approach that we'll be going with here is min heap. Just keep in mind, we'll be going with the min heap priority queue or just min heap to efficiently extract the k closest points, right? This one approach will be going with min heap. Just keep this one in mind. Let's discuss the step by step approach. First, what we will do, we have to compute the squared distance here. We have to compute here squared distance, right? This will be the first step. Square distance is nothing but d square equals x square plus y square. We have already considered this one, right? For each point x comma y, what we'll be doing, we will be computing d square equals x square plus y square. That's what we'll be doing here. Nothing but we are computing the squared distance. No need for the square, this one. No need for square root. We have already discussed this one, right? This will be the first step. Second step is insert. Will be insert into min heap. We have to insert the values into min heap, right? So insert into min heap. This is fine. This will be the second step. When I say insert into min heap, we have to store each point in the min heap where key is the square distance. So we have to insert each point into min heap where key is nothing but squared distance. Where key is squared distance. And second thing is a distance, a min heap keeps the smallest elements at the top. That we know. Min heap always keeps the smallest element at top. So we know that a min heap always keeps the smallest elements at the top, allowing us to extract the k elements, right? K smallest distances efficiently, right? Next step, let's see how can we extract the k smallest elements. Here we have to extract k smallest elements, right? We have to extract here k smallest elements. So extract the top k elements from the min heap. We are just extracting. In this case, we'll be making use of the extract function within the min heap. If you are knowing the min heap, we can go with the insert extract functions, right? Within the class. So we'll be making use of the extract here. Extract function. Within the extract, what we are doing, we are extracting the top k elements here. We are extracting the top k elements from min heap. So that's what we'll be doing here. We are extracting the top k elements from, I'll just write here, min heap. Then finally, these k elements will be closest to the origin 0, 0, or these k elements will be closest points to 0, 0 in this case, right? So this is how we'll be solving the problem. So this is the approach that we'll be going with. First thing is, for each point x comma y, we are computing d square equals x square plus y square. We saw this one. Second thing is, inserting into min heap, nothing but we have to store each point in the min heap, where key is the square distance, and min heap keeps the smallest elements at the top, right? At the top always. We know this one. Final step is extracting the k smallest element. So how do we extract here? Extract the top k elements from the min heap. Always we are extracting the top k elements from the min heap. These k elements will be closest elements to the origin 0, 0 here, right? So this is the approach that we'll be going with. So let's dry run the example 1 accordingly with the approach. I assure you that you'll understand this one very clearly. So here I have considered the first example that they have given in the question. Same example I have considered here, right? So we need to find the first closest element to the, one closest element to the origin 0, 0. That's what we need to find. As they have given k equals 1, we need to find the one closest point to the origin 0, 0, or the first closest element, first closest point also we can say to the origin 0, 0. First step, what we will do, we have to compute the square distance according to the approach, right? We have to compute squared distance in this case. So when I say compute square distance, we will calculate the squared Euclidean distance for each point to avoid the unnecessary square root. So first let's consider this one, 1, 3. So here we know that formula is nothing but here in this case d square equals x square plus y square. Here in this case it will be 1 plus here 1 square plus 3 square, will be considering nothing but 1 plus 9 here. It will be 1 plus 9. This will be 10, right? So this one let's consider minus 2, 2 here. This one same formula will be going with. So this will be minus 2 square plus minus 2 square plus of this one plus 2 square right here. This will be 4 plus 4, nothing but 8. Now we have got 10 and 8. I hope this is clear. We have just computed the squared distance. This will be 10 and 8. Let's move on with the second edge case. Second step, sorry. This will be storing the points in min heap. We have to store the points in min heap, right? Store points in min heap. This will be the second step. And here min heap keeps the smallest distances at the top. We have discussed this one. We know this one crystal clear, right? So crystal clearly we know this one. A min heap keeps the smallest distances always at the top. So we are inserting the smallest one, right? So we have out of 8, 10, 8 is the smallest one, right? 8, here will be inserting minus 2, 2 in this case. Next one we have here is 10. 10 and 1, 3, right here. 10, 1 and 3. This will be first because min heap keeps the smallest distances always on the top. So this one will be first and this one will be second. This will be the second step. Let's move on with the third step. Nothing but extracting the k equals 1 smallest point. We have to extract here k equals 1 smallest point. They have mentioned k equals 1, right? You can clearly see here k equals 1. So only 1 point we have to display in the output. So here accordingly with the approach, since 8 is less than 10, we have 8 and 10, right? When we compute this one, when you compute square distance, we have 8 and 10. Since 8 is less than 10 here, the closest point is this one. We are considering the first one, nothing but minus 2, 2 in this case. I hope this is completely clear. Final output will be minus 2, 2 here. I hope this is clear. I hope this is completely clear. Next, let's discuss the edge cases step by step and then finally write the code. So let's consider the first edge case, nothing but minimal input case here. So I'll just write here minimum input case. So in this case, input, let me consider here input points here. Let me consider 1 we have to consider, right? I'll just give you a 0, 1. K, let me consider 1. So the output here will be 0, 1 itself. Why the output here is 0, 1? Because we have only one point here. So K is also K equals 1 we have. So only one point is given here. We will return that itself. So the output will be 0, 1. This is for the condition minimal input case. Next, let's discuss all points at same distance. Let me give here all points at same distance. When I say all points at same distance, let me consider the input here. Points equals 1, 1, minus 1, minus 1 here, and 1, minus 1, and same thing, minus 1, 1, and here let me give K equals 2 here. So here output we can consider any 2 points because all the points are same, right? All the points are at the same distance, right? So we can just consider any 2 points. Suppose I'll just give here output in this case 1, 1, and minus 1, minus 1. So we can just consider any 2 points here because all the points are at the same distance. All points are at the same distance from 0, 0.0. That's what I'm telling here. Any K points can be chosen, right? So I hope this edge case is completely clear. This is for the condition all points are at the same distance. Let's move on with the third edge case or the final edge case here. Negative and positive coordinates. This is for the condition positive and negative or negative and positive coordinates. Coordinates, right? So this is fine. Negative and the positive coordinates here. Let me consider the input here. Points equals minus 5, 4, 3, minus 3. We should have positive and negative coordinates, right? Anything you can consider 1, 1. In my case, I'll just consider this one just for the understanding purpose. K equals 3. Let me consider here. We have to display 3 points that is close to the origin 0, 0. So the output will be here 1, 1, and 2, 2, and 3, minus 3. You can just dry run this one. I have shown for the example this one. I have just considered the example one and we have dry run the same thing, right? Same example. So I can just dry run this one. You'll get the output same here. 1, 1, 2, 2, and 3, minus 3, which are close to the 0, 0 origin, right? So we correctly chose the closest 3 points based on their square distance. You can just calculate in the same way that I had shown for the example. So what are the edge cases that we considered here? First one was for the minimal input case. Second one was for the all points at same distance. Third one was for the positive and negative coordinates, right? I hope all the edge cases are clear. Now let's start writing the code. I'll just explain the code while writing the code itself, and finally let's discuss the complexity of the code that we have written. Now let's start writing the code. So initially what we'll do, we have to convert each point into distance square, nothing but the square distance, point within the array, right? And then we have to store that one in the min heap. So I can just write in this way. H equals heap I'm considering here, new min heap, square distance we have to consider, and point we have to consider, right? Within the array we are going. So I'll just make use of the map here in this case. So anything you can consider, I'll just consider random variable a here. So distance square is nothing but x square plus y square, and point we have to consider x square plus y square. We have to make use of the exponent operator here, right? I can just give here in this form. So within a, this one, a of 0, this is nothing but the exponent operator, plus a of 1 to the power of 2, and distance square and also the point we have to consider nothing but A here. I hope this step is completely clear. So we are just converting each point into the squared distance, comma, point, and we are storing that one in the min heap. That's what we are doing here. So next step is we have to extract the k closest points. For that one, we need extract, right? So let's build the min heap here. So min heap here. So within min heap, we just have to extract the k closest point. So considering the extract function is enough here. So for that one, first we'll go with the initialization. I'll just be making use of the constructor. So let me pass a here. This is fine. We have to sort the array by square distance and ascending order. So here we are sorting the array by square distance and ascending order. Just keep this one in mind. Let me consider here heap equals, we are sorting in ascending order. So I'll just consider here x comma y, x of 0 minus y of 0. We are doing this one sorting in ascending order, right? So x minus y. So I hope this is clear. Next, we have to extract the k closest points. For that, we have to have the extract function. So I'll just give here extract. So let me pass the k. So we are extracting the this one k closest points we have to extract, right? That is the reason I'm passing k here as parameter. So let's extract first k elements, nothing but smallest distances, and then return only the, and then we will return only the points. How can I write this one? I can just articulate in this way, right? In the form of code, I can just give here this dot heap, but I'll just slice from 0 to k. Because why am I slicing here from 0 to k? Because we need to extract first k elements. That's what they have asked in the question. So here, let me map this one. X, any random variable, this one will be x of 1. I hope this is clear. We are just extracting the first k elements. You can clearly see here, this one has to be 0, not O. Let me make this 0. Yeah, this is fine. We are extracting the first k elements and return only the points. We are returning only the points here. You can clearly see. That's what we are doing here. So here, let's come to the main function here. So finally, first what we have done here, we have converted each point into square distance, comma, point within the array, and we have stored that one in the minimum heap. That's what we have done. Next step is here, this is simple. We have to just extract the k closest points. So let's return h dot heap dot extract here. Extract function we have written while building the heap. You can clearly see here this one. Extract. What we have to extract? We have to extract k closest points. Nothing but k here. Let's pass k here. This is it. So let me format the code once and let me hit the run button. So runtime error we are getting here. P is not defined. So just give me a second. P and K. So here points I have considered, right? So this is fine. Let me give here points. Let me hit the run button again. So now you can clearly see the sample test cases are getting passed here, right? So let me hit the submit button now. So you can clearly see all the test cases are getting passed. So the code works absolutely correct in this case. I hope the solution is completely clear. So let's quickly discuss the time complexity and the space complexity of the code that we have written. So the approach that we went with here is min heap or the minimum heap. We know this one. So what will be the overall time complexity here? In this case, overall time complexity would be big O of n log n. Why the overall time complexity here would be big O of n log n? Because sorting the array takes big O of n log n. We know that. And extracting k elements takes only big O of k. So overall time complexity here, sorting is dominated. In this case, sorting dominates. So the overall time complexity would be big O of n log n. So what will be the space complexity here? The overall space complexity would be big O of n. Why overall space complexity here is big O of n? Because We know in the previous problems also we have discussed the same thing. Heap can store up to big O of n, means it can store all the points, right, requiring big O of n space. So overall space complexity would be big O of n. The time complexity would be big O of n log n, and the space complexity would be big O of n. I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.